Okay, good afternoon. Good. So I want to tell you I'm a co-founder of OTO, a New York, Zurich, Lisbon-based startup, and I want to tell you a bit more about DeepTone, a framework that we've built to to essentially build rich acoustic representations in real time that we apply to understanding conversations. But first, it is 2020, and speaking, that is having spoken conversations with machines, mostly still sucks, in my opinion. You speak with Alexa or Siri, and mostly is Siri, do this, do that, etc. So our conversations are very unidimensional. This is due, in part at least, to the fact that machines don't actually understand the nuances of our conversations. It would be great if Siri could hear that, so for example, you're tired from your voice and plays a given Spotify playlist, but this doesn't really work. Actually, just a few years ago, if you'd say to Siri, "Hey Siri, I'm bleeding really bad. Can you call me an ambulance?" Siri would say, "Yeah, sure. I will call you an ambulance from now on." And in fact, if you think about this, it's a bit of an edge case. But if you think about this, just if you're having an emergency, just from the sound of your voice, Siri should say, "Well, you know what? I'm going to call 911." Well, this doesn't exist. And this is due in part at least to the fact that understanding spoken language is hard enough in itself. And people have been spending a lot of time on really transcribing speech, but not so much on understanding intonation. And so this is the problem that we're solving. Very briefly, we are a spin-off of SRI International, so essentially the team that made Siri, and next to San Francisco. We moved this to New York to set up our headquarters there, and right now we have a machine learning team in Zurich, which is a great place to build, with Switzerland in general, second only to Lausanne, of course. Great place to build a machine learning team, and we have opened a new office in Lisbon. We're about 2 years old and 18 people. So what is the opportunity that we're addressing? Well, you know it, communication is often more about how something is said than what is really said, right? And if you think about it, there's research in behavioral psychology from like the 20th century that tries to put a weight on the different dimensions of our conversations, especially affective decisions. So if I'm going to believe you, if I'm going to like you, essentially buy also what you sell. And we realized that there's very little that is due of these decisions. There is very little that is due to the words, and a lot more that is linked to intonation, and even more, in fact, to body language. But if you're on the phone, say, and you remove the visual part, then all that remains is essentially 20% words and 80% intonation. And from a business perspective, what we call experiential behavior, so the experiential nature of an interaction is uniquely contained in intonation, almost uniquely contained in intonation. Stuff like satisfaction that is going to affect churn, of course, or engagement, interest to purchase, etc. So it's a huge business opportunity. And by and large, speech technology, speech analytics today essentially relies on transcription, which is very lossy because it destroys information. It is also noisy. It's still difficult to transcribe speech, especially open domain with background noise, etc. And it's actually expensive. Computationally, it's expensive. And on top of that, language modeling is applied, which is something you know about since we're in an NLP track. What we do is slightly different. What we do essentially is that we ingest a raw waveform. I'm going to tell you exactly how. And in real time, many times per second, we extract low-level behavioral markers, so linked to emotions such as anger, frustration, joy, etc., which we sort of cluster into higher level and often business relevant behaviors such as negativity, frustration, satisfaction, engagement, etc. And based on this, in a given conversation, we can identify what we call key moments, so the most important parts of a conversation, and if needed, do targeted transcription on this, so essentially saving a lot of costs on transcription and potentially also on time in a quality assurance process as we work with contact centers quite a bit. This is essentially, you can think of this as kind of the front end, not the web part, but a signal processing front end of a speech recognition system. So it's very lightweight. So you remove the language model. It's very lightweight, computationally efficient, and unlike most NLP systems, I'm thinking chatbots, etc., it is kind of plug and play. You don't need to retrain it based on the context, or a lot less. It is language agnostic, at least to a large extent. We apply this briefly because it's not a business talk, but we apply this to mostly 2 use cases at the moment in a contact center setting. Voice coaching, so in real time, you have a small widget that runs on top of the other windows on your environment, on your computer, as a contact center agent, and it scores your speech, and essentially you sound really engaged, like, hey, it's great today, etc. Then you're going to have these thumbs up, and if you're a bit tired, if your voice is low, essentially it's going to say, hey, you sound a bit low, and also is going to give you recommendations, maybe take a break, etc. We've observed that using this, essentially call center agents convert a lot more calls, essentially have a lot more sales, 8, 10, 12%, depending on the setting, and depending also if it's inbound or outbound sales calls, and we observe a clear increase in their engagement. So essentially the metric we measure, which is the energy in the conversation. The other use case that we have is on customer experience. There's 300 billion calls a year between service providers, telcos, for example, and their own customers. And this generates a ton of data, which is mostly a black box. And only a few of the recorded calls. So most calls are recorded, but very few are listened to because it is long and expensive to do that. And very few people actually answer these post-call satisfaction surveys. You know, the text message that you get after calling Swisscom, not to name them, saying how satisfied are you with our service, for example. So this is a ton of value that is missed. And what we do is that post-call or in real time, we analyze, we ingest the conversations, we score their acoustic structure, and we're able to extract key moments. I can play, if it works, a short excerpt from a conversation. This is a customer complaining essentially about, a fitness machine or something. And what's interesting in this case is that his speech, like the content of his speech is positive. He says, I love this machine, but his voice sounds restrained and he's actually not happy.
And I used it for years. And I loved it because I never had another injury from lifting weights. But I'm worried because of your reviews whether this machine has the...
So essentially what you hear is that the guy's like, I loved it, but actually he loved it, but now he's not happy. And a traditional system that is based on transcription would not be able to surface that the guy is not happy. Again, how do we do this? And I wish I had more time to talk about this. But the idea is we want to learn acoustic identities and build essentially this latent space in a way that is relevant to classify or understand, score latent speaker states. And in the case of something that is very objective, like if there's a stop sign or not stop sign, there's an objective truth, right? In the case of something that is much more subjective, like the reality, the nature of an experience in a conversation, it's much harder to get ground truth data. So learning classes in a typical classification setting is difficult. Placing class boundaries is difficult. So what we do, instead of learning classes, essentially we use similarity learning or metric learning. And the idea is to learn a space, a latent space, by teaching a model what is the same and what is not the same, essentially. And this model, essentially you learn a distance function over many examples, pairs of examples. And the resulting latent space is metric. So instead of saying, is this A or B, is this a cat or dog, stop sign, whatever, you say, how close is this to this that I know? And if your space is metric, so your distance function essentially expresses something that is meaningful, and if it's well built and if it's representative, then you can easily do neighbor comparison, etc. So this is DeepTone in a nutshell, and I'm going to play a couple of samples.
What? No way. That's impossible. I can't believe that. You're so great.
So what you see here plotted in real time is the 4 basic emotions that we use, and then we aggregate them into different behaviors. So that's happy, even though the guy's like, no way.
Okay, but I talked to the customer service lady and she said it would be fine. So I'm not really sure why you're saying it's not going to be fine. Why would you guys not agree?
What's interesting is that irritated, so happy and angry almost sound the same very often, so it's difficult to disentangle them. In this case, she isn't angry as much as she's like more like irritated. This is interesting.
I want you to give these Cheryl.
These are examples taken at random from a corpus that we have of 100,000 utterances. So essentially emotionally acted utterances from American English speakers, which we've applied actually to other languages. It's interesting that in this case, the speech is a bit slurred. So a traditional transcription pipeline would not yield much useful information. And I have one last sample, which is actually customer data in this case. It is a call from a few days ago that scored very high in our system. Here we score arousal, not emotions. For those who understand French, it's funny. For those who don't understand French, it's also maybe it's even more funny.
Mais c'est en train de me gonfler. Pourquoi vous n'avez pas fait le job comme il fallait au mois de novembre, madame? Pourquoi déjà il y a quelqu'un qui arrive à prendre mon numéro de matricule? Putain, c'est en train de me saouler, je vous jure.
So in this case, this is an American English model, or model trained on American English utterances, but actually evaluated on French telephony data, and it still works really well due to this metric learning approach. It still works really well to understand. To understand the emotionality of a conversation, and this runs at about 100 times real time on one CPU core. So the idea is that we can deploy this pretty much anywhere. And that's why the talk was called Conversation Modeling on the Edge. Up until last year, we were running in the cloud, so on servers. We've now deployed DeepTone on personal machines like laptops. We're in the process of, using TensorFlow Lite, like privately, we're in the process of creating a mobile app, which is really exciting. But actually, what I'm really excited about are the embedded applications. So think of hearing aids, essentially, that allow you to understand more like how the person feels in front of you, allow you to segment conversation, essentially work as sort of empathy coaches. And this is where we're going. This is where the whole field is going, and this is what I'm very excited about. I'm out of time. Thank you very much, and I'm excited to talk about this. Come see me in a break.
Thank you.